All right, well, let's do our last related rate type of problem. So by now you know the kind of the process. So let's read and figure it out here. A TV camera at ground level 3 kilometers away from a launch pad is filming the liftoff of a space shuttle that is rising vertically at a rate of 1/12 kilometers per second. Find the rate of change in the angle of elevation of the camera when the shuttle is at an altitude of 1 kilometer. Okay, so see if you can kind of stop the video and draw the picture. You have a TV camera. It says it is 3 kilometers away from the launch pad, and the space shuttle is going up. And it's rising vertically at a rate. So I'm going to call that h, just the height above the ground that the space shuttle is. So your given would be dh dt is 1/12 kilometers per second. What are we finding? Find the rate of change in the angle of elevation of the camera. So as this camera, obviously it's focused on the shuttle when it's on the ground, and as it rises, it doesn't just stay that way, it rotates so that it can actually film the shuttle, and so that's what it's asking. Remember, angle of elevation and angle of depression are always with horizontal, and so you're trying to find d theta dt when, what did it say? The shuttle is at an altitude of 1 kilometer, so that means the height is 1 kilometer. Okay, so there's your given and your find when statement. So what's next? Write the relating equation, and we get trig in there. So in this problem, looking at the relationships of the sides and the angle that we have, the best trig function, of course, you have the opposite and you have the adjacent. So opposite and adjacent, you're going to say that the tangent of theta is h over 3. Opposite over adjacent. Now, does that mean every trig one you're going to use tangent? No. You have to look at your picture and see what you're given and pick the best one. So, but in this case, it's going to be tangent. After I do my relating equation, of course, I do the derivative with respect to time, and remember that theta is a variable. So the derivative of tangent is secant squared of theta d theta dt. That gets forgotten a lot. Now, believe it or not, on the right-hand side, many people miss this, or they make it too hard. Think of that right-hand side. Isn't that really 1/3? I'll just write it up here. Isn't that really 1/3 h? So I don't have to do the quotient rule. I mean, I can, but it's much faster just to say, oh, that's 1/3 dh dt. And it's just like that. Okay. Now let's keep going. Well, here's the weird part is at this point you're like, well, I can fill in what I have. What's bizarre is I have this secant squared of theta. Now, for the purposes of this problem, we're going to solve for d theta dt. So I think we're going to say, well, I'd have 1/3, I'd have dh dt. And if I were solving, should have left myself some space, if I were solving for d theta dt, wouldn't I divide both sides by secant squared of theta? Do you agree with that? And then on the left, I would have d theta dt. And if I have secant squared in the denominator, isn't that like having cosine squared? And I'm just going to write it this way in the numerator. So I could say d theta dt is 1/3 dh dt times the cosine of theta squared. Now let's start filling in. Well, d theta dt is what I'm looking for, so it's okay that I don't have that. 1/3 dh dt was 1/12. Then I get to this cosine business. And as we've talked about, well, after you've taken the derivative, if they didn't explicitly, of course, tell you what cosine was, but you have enough information to get it. And I want you to put a big star right here And people always go, how do you get that trig? You want to do a relationship of the sides. Relationship of the sides. Notice I am not doing this with a calculator. I don't care what theta is. I just want to know what the cosine of theta is. So let me draw our snapshot picture, because I know if I do that and I label this as 3, and in the moment we're talking about h is 1, and I said, guys, I need you to get me the cosine of theta, I know that you could do it. Because you'd say, oh, well, I just used Pythagorean to get that third side. So 3 squared plus 1 squared. This side is going to be the square root of 10. And then cosine, so katoa, is adjacent over hypotenuse. So the cosine of theta, again, you have enough information to get it. That's what I'm going to plug in right here in squared. And once you have that, you're kind of at a pretty easy spot, right? Because what I really have, and technically you don't have to simplify, but I'm going to in case this were multiple choice. I have 9 over 10 because I square the top and square the bottom. This 3, that 3, excuse me, that goes away, and I can have 3 there, and then that 3, and that goes 4. So my answer would be 1/40th. Do a little reducing there. D theta dt is going to be 1/40th, and I will go ahead and write my sentence. I go back and read the question. When the shuttle is at an altitude of 1 kilometer, the angle of elevation is changing at a rate, I'll just put is increasing. I mean, I could put is changing, but again, I like to interpret it as positive, which makes sense. Increasing at a rate of 1/40th. Now let's talk about units. Units for angles, again, we're always in radian mode, so it's always radians per time. So in this case, it was seconds, right? If we look back, it was kilometers per second. So our angle is going to be radians per second. So the shuttle is at an altitude of 1 kilometer. The angle of elevation is increasing at a rate of 1/40th radians per second. So there you go. That's how you do it if there's trig. This is the key part that people miss. I will tell you the most missed things I see. First of all, people forget the d theta dt. They forget that theta is a variable. And then secondly, they get stuck right here because they don't know how to get the trig, that piece of it. So remember, you're going to do it by the relationships of sides. Draw your snapshot picture, do SOHCAHTOA, and get that trig. All right. Well, good luck on the homework. Peace out.